Welcome to the deep dive. Buckle up, because today we're going deep on a mind-bending concept. The multi-cycle universe.
Yeah.
A cosmos that doesn't just end, but cycles through like periods of expansion, contraction, and then rebirth. We've got your notes and excerpts here, and I have to say, it's pretty wild stuff.
It's a really fascinating concept that, kind of like you said, challenges our conventional understanding of how the universe works. Instead of this single Big Bang and then, a finite endpoint, imagine a universe that's constantly evolving through these cycles, driven by the enigmatic power of quantum singularities.
Quantum singularities, huh? Those points of infinite density and energy, they sound pretty intense. Are you saying they're like the engine behind each cycle of the universe?
That's one way to think about it, yeah. The notes he sent, they suggest that instead of leading to a big crunch, the universe's expansion, it kind of pushes these singularities to their limits, where they could potentially rip, merge, and evolve, and that kind of sets the stage for a new cycle.
Okay, so if the universe keeps expanding, wouldn't the singularities be getting further apart? How could they possibly merge? I'm trying to picture this.
Right, yeah, that's where the concept of spacetime curvature comes into play. Einstein's theory of general relativity. It tells us that mass and energy warp the fabric of spacetime. And singularities, with their, infinite density, create the most extreme curvature well imaginable.
So even though the universe is expanding, these incredibly dense singularities are warping spacetime so much that they're actually drawn together.
Exactly. Now, to understand how a singularity's power might change throughout these cycles, we need to look at this thing called the Schwarzschild radius.
Okay, that rings a bell. Black holes.
Right. Essentially the radius of a sphere around a singularity where gravity's so strong that nothing, not even light, can escape.
So each singularity has an event horizon that expands as the universe grows. Is that kind of what we're saying?
Good way to think about it. And what's interesting is that the Schwarzschild radius is directly related to the mass or energy of the singularity. Your notes here even include a simple equation to illustrate this,
Okay.
We don't have to get into all the math right now.
No. The key takeaway here is that as the universe expands and the singularity potentially gathers more mass energy, its Schwarzschild radius, it would increase.
So each time the universe goes through a cycle, these singularities are basically becoming more powerful. Like, imagine a snowball rolling downhill, and as it rolls, it gathers more snow.
Precisely. They become more massive, their gravitational pull intensifies, and their influence on the fabric of spacetime, it grows even stronger.
Yeah.
This evolution of the singularities could be what drives the universe's cyclical nature.
This is already blowing my mind. But then your notes go on to suggest that time itself could be affected by these singularities, specifically their spin. How does that even work? Well, it is a very mind-boggling concept, yeah.
Right.
But the source material here draws a fascinating parallel. Think of a spinning top. The faster it spins, the more energy it has, right?
Yeah.
What if a quantum singularity is like that spinning top and its spin is somehow connected to the flow of time?
So a faster spin means time speeds up. Is that the basic idea?
Basically, yeah. Each cycle of the universe could actually be shorter than the last as the singularity's spin, potentially increases. The source, it even provides an equation that tries to describe this relationship. It looks like this. T for 4S.
Okay.
Where T is time, S is the singularity's spin, and E naught is Planck's constant, a fundamental value in quantum mechanics.
Hold on. If each cycle is getting shorter due to this increasing spin, wouldn't that mean things would get pretty chaotic pretty fast? I mean, would there even be enough time for stars and galaxies to form if the universe was constantly speeding up?
That's a great observation, yeah. It raises the question of how the laws of physics might change or adapt in such a scenario. The source material doesn't really dive too deep into that, but it certainly opens up, a whole new realm of possibilities to explore.
This is a lot to process.
Yeah.
We've got singularities merging, potentially warping spacetime, time itself speeding up with each cycle, and who knows what's happening to the laws of physics. My head's spinning.
Take a deep breath. We're just getting started with this deep dive. But before we go into how any of this could be measured, let's shift gears a bit and explore how this spin might actually connect to something, a bit more tangible. The light coming from the very early universe.
Okay, I'm all ears. Let's see where this goes.
Yeah.
So we've got these singularities. They're spinning faster and faster, and somehow that's connected to the light from the early universe.
Yeah. So we have this baby picture of the universe, right? It's called the cosmic microwave background. The CMB.
I've heard of that.
It's basically the faint afterglow of the Big Bang, and it provides a wealth of information about the universe's, early moments.
How could it possibly tell us about these previous cycles and speeding up singularities, it seems like? I don't know.
Yeah, it might seem far-fetched, but think about it this way. In a multi-cycle universe, the CMB wouldn't just be a snapshot of one Big Bang. It could contain echoes of those previous cycles, like layers of, cosmic history imprinted on this light.
So you're saying there might be like subtle differences in the CMB on which cycle the light originated from?
Yeah. We'd be looking for variations in the frequency of this light, this ancient light.
Frequency, like how high or low a sound is.
Exactly. Light travels in waves, and the frequency of those waves determines its energy. In this model, as the singularities gain more energy with each cycle, the light emitted during the Big Bang of each cycle would have a progressively higher frequency.
Okay, so higher energy singularities mean higher frequency light from the Big Bang. But how could we even measure those differences? Wouldn't the light from all those cycles just, I don't know, blend together?
Well, that's the challenge, but the CMB is incredibly faint to begin with. If we could analyze its spectrum across different regions of the sky with extreme precision, I mean extreme, we might just be able to detect those subtle frequency variations.
Wow. To actually have evidence of these previous cycles encoded in the light itself?
Yeah. The source material even includes an equation. It tries to model this increase in frequency. It looks like this: OPEC cycle plus N delta F,
Wait.
where F represents the frequency, with cycle indicating which cycle we're looking at, N is the cycle number, and F is the frequency increment from one cycle to the next.
So if we're right, we could potentially map out the frequency of the CMB and see if it matches this pattern of, increasing steps.
That's the idea. Now, this brings us to an even more abstract concept: the ever-increasing frequency wave function.
Okay. Wave functions. This is where I might need a little help.
Yeah, to put it simply, the wave function in quantum mechanics is basically a way to describe the state of a system, including all its possible outcomes and their, probabilities.
So we're talking about the wave function of the entire universe.
Exactly. The source material suggests that just like the frequency of the light we discussed, the frequency of the universe's wave function might increase with each cycle. Imagine it as a cosmic echo that gets stronger and more complex with each repetition.
So the universe isn't just expanding, it's also vibrating at a higher and higher frequency. Does that mean it's like gaining energy overall? What does that even mean for reality?
Those are some excellent questions, yeah. The source material doesn't have all the answers, but it does provide this equation to illustrate the increasing frequency of the wave function. I know it looks a little daunting.
Yeah, a little.
Yeah. The takeaway here is that Nn represents the angular frequency of the nth cycle, and it increases over time. This means that the entire wave function, which describes the universe's state, is also, evolving along with it.
Hold on, I'm trying to keep up.
Yeah.
So each cycle isn't just a repeat of the last one. The universe is actually changing, becoming, I don't know, more complex, more energetic with each iteration.
That's one interpretation, and it's a very, very fascinating one. But the implications of this ever-increasing frequency wave function, don't stop there. It leads us to the question of, well, how might the very fabric of reality itself change with each cycle?
Okay, now you've really got my attention. What could these changes look like? Are we talking about like new laws of physics emerging, new forces?
That's precisely what some physicists speculate, yeah. Remember those singularities?
Yeah.
Those points of infinite density. They're governed by quantum mechanics, where, randomness and probability reign supreme. As they evolve with each cycle, they might bring forth new fundamental forces, or even, new properties of matter.
So every cycle could be like a grand experiment, with the universe trying out new combinations and possibilities.
It's a beautiful thought, isn't it? Kind of humbling, but where does this constant evolution lead? That's the next question.
Lead the way. I'm ready to dive deeper into the potential futures of a multi-cycle universe. Okay, so we've talked about spinning singularities, a universe with, increasing frequency, and the possibility of reality itself changing with each cycle. Where does it all lead? What's the future of a multi-cycle universe?
That's where things get, I don't know, really speculative. But the source material does offer some intriguing possibilities. One scenario is like a steady state of increasing sophistication. Each cycle builds upon the last, becoming more complex, but without a definite, endpoint.
It's like an endless staircase
Yeah.
leading to ever greater levels of complexity. Does that mean the universe is always I don't know, getting more interesting, more diverse?
It's a fascinating thought, yeah. Imagine new forms of matter, new forces of nature, maybe even new dimensions unfolding with each cycle.
But what about the singularities themselves? They're gaining more power with each cycle, right? Couldn't they, I don't know, eventually disrupt this whole process of increasing complexity?
That's a good question, and that's where the other scenario comes in. The source material suggests the possibility of an eventual convergence. Imagine all those powerful singularities, those points of infinite density, collapsing back into a single point, a reunification of all that energy and complexity.
So instead of an endless staircase, it's more like a cycle within a cycle. A big crunch that sets the stage for a new big bang, but with all the accumulated complexity of the previous cycles kind of folded back into it.
Exactly. It's a captivating idea, but you're probably wondering if there's any way to actually, test any of this. It all seems so far beyond what we can do.
You read my mind. We talked about searching for evidence in the cosmic microwave background, but are there other ways to, validate this multi-cycle model?
The source material highlights a few other avenues, yeah. We could develop more sophisticated theoretical models to predict how singularities might behave across multiple cycles, right? These models could then be tested against observations of distant galaxies and other cosmological, phenomena.
So refine our theories and then look for evidence that either supports them or contradicts them. The classic scientific method, but on a cosmic scale.
Precisely. Another area of research would be to study dark matter and dark energy. These mysterious entities make up the vast majority of the universe's mass and energy, and they could play a, crucial role in the dynamics of a multi-cycle universe.
It seems like every answer just leads to more questions. This whole idea of a multi-cycle universe really challenges, like everything we know about existence itself.
Yeah.
If this model is even partially correct, what does it tell us about our place in all of this?
That's the ultimate question, isn't it? Are we just a blip in one cycle of, I don't know, an endless cosmic dance? Or are we somehow part of something much, much grander, a universe that learns and evolves through these cycles, with each iteration building upon the last?
It's both humbling and awe-inspiring at the same time. I have to admit, I'm a bit overwhelmed by the sheer scale of it all.
It's certainly a lot to process, but that's the beauty of scientific exploration, isn't it? It pushes us beyond what we're comfortable with, forces us to confront the vastness of the unknown.
I want to thank you for guiding us through this deep dive. It's given me a whole new perspective on the universe, and our place within it.
The pleasure was all mine. And to all our listeners out there, we encourage you to, dig into the source material yourself and explore these concepts further. The universe is full of mysteries, and the journey of discovery, well, it's just beginning. Keep questioning, keep exploring, and keep diving deep.